Hi, I am a tutor with Uplatz, and today we are going to discuss simple introduction to MATLAB. MATLAB is an acronym that stands for Matrix Laboratory, first conceived by Cleve Moler in 1978 to facilitate matrix-based computations through an interpreted environment. Tool became very popular among numerical analysts and engineers. Basic environment supports numerical, symbolic, and graphic computing. Several toolboxes are available to support computations of a specific engineering discipline. MATLAB can be viewed as an extended calculator. You type in commands and the answers are displayed immediately. Arrays are defined automatically. That size can grow as the need arises. MATLAB is also a programming language, exploits object-based design. Once an object is created, its properties can be integrated and changed dynamically during its lifetime. Full support to define your own data types and overload all the operators. MATLAB environment is ideal for rapid application development. For further speed up, there is a compiler tool that returns your MATLAB code into an executable files. This is the MATLAB environment. First, as soon as you come here, you can say what is present working directory to know in which directory you are. If this is not the directory you want to work, then you can go here and then navigate like this, the drive, and within the drive, the folder and subfolders and all, and then select this one. And once you selected, you are in the you are in the environment where you want to work. Moreover, you can always give clear CLC to clear everything, and also give clear all to give anything in the workspace. This is a workspace. Anything in the workspace can be cleared using this. And this is the current folder. Information is here. Now coming back to the slides, Cleve Moler in his MathWorks site has put a very interesting hypertext page from which we can learn more about the MATLAB. It is a myth that MATLAB is slow. Think again. MATLAB is extremely fast for matrix computation. MATLAB is an encapsulation of a highly optimized lab pack, linear algebra package, and Balazs numerical library. We can do an experiment of matrix computation for a size of 500 by 500 using C and MATLAB. Even though a very compact code is used in C, it takes 4.08 seconds, but MATLAB takes around 0.53 seconds, almost 8 times faster than C. Don't expect your tiny C code will beat MATLAB for matrix operation. MATLAB is slow only when you make it to slow. MATLAB, like any other programming language, is a fully power programming language with full control capability of other high-level languages like if, then, else, for, and, while, and, try, catch, and. In most cases, you don't need to need them at all if you do things right. That means there is a very efficient way of programming in MATLAB. In such cases, you need to use these control statements. MATLAB is not MATLAB, it is Matrix Lab. Think everything matrix, okay? And now let us to learn the MATLAB programming language. We'll have an online demonstration of solving a system of equation, how different arrays are defined, difference between star and dot star, location of maximum elements, counting elements, and simple plots. a quick walkthrough of how to solve the equation x plus 3y is equal to minus 2 and 2x minus y is equal to plus 3. Matrix is defined by enclosing its elements within square brackets, and the elements are separated by blanks or a comma. Rows are separated by semicolons. For example, I input the matrix needed, that is 1, 3. It's a first row. Separated by semicolon to indicate the beginning of the second row, that is 2 minus 1. And this one. Semicolon at the end of the command suppress the output of the screen. Suppose since I want to show the matrix, I'm not putting semicolon. So you see the matrix. Now, similarly, you can enter B is equal to minus 2 semicolon 3, because I want a column matrix. So I get a column matrix. Now, make sure that matrix dimensions agree. Naive approach is to solve using the equation x is equal to INV of where INV is the inverse of A is a MATLAB function. When I put that, I get the answer. X is equal to it took some a while for the output to come, but there's a faster way of doing it in MATLAB. When I put x is equal to A backslash B, you see the incredible speed with which it comes. Yeah. So either way, the answer to the problem is x is equal to 1 and y is equal to minus 1. Commas concatenate horizontally, semicolons concatenate vertically. Let me clear the screen and then say clear all the workspace to get ready for the next problem. Then moving to the next demonstration, we defining arrays. Okay, we can define arrays by putting x is equal to minus 2 to 2 is the range with interval 1. Implicit interval is 1. So it will generate minus 2, minus 0, 1, minus 0, 1, 2 as the array x. Now, we can also give arbitrary intervals by saying x is equal to minus 2, 0.5, 2. Then it generates at intervals of 0.5 numbers from minus 2 to 2. Now, there is another way of generating a matrix space or line space by putting x is equal to a line space of, you can say, the range of numbers and how many numbers you want within this range is specified as the third number. And then when you input it, you get the numbers. That means here I have put the range as minus 2 to 2. I wanted 4 numbers, so it generated minus 2 minus 0.667 plus 0.667 and 2. Yeah. Square brackets around the vectors are optional. However, if you want to transpose the vector at the time of definition, you do need the square brackets. For example, I say x is equal to minus 2 with interval 0.5 to 2 within square bracket, and I put apostrophe to generate it as a results in a column. Yeah. So dot apostrophe product produces a non-conjugate matrix. For example, that we clear all and input the matrix A, which is a complex matrix, is equal to 1i, where I is the imaginary number and 0 I is my matrix. So this is the matrix. So you know that this matrix is a complex matrix. Suppose they say A transpose, it produces a conjugate transpose in the sense the imaginary terms are come with a negative sign. Suppose I want a non-conjugate transpose, then I say A dot transpose. When I put that, I get the non-conjugate transpose. Note, I can also get this. Suppose I get the size of a matrix using the command size of the matrix, whatever it is, from 1 to -1. You expect 0, 0 to come as the dimension, but we will get a dimension of 1/0 only. So, and we can also use a repeat mat, REP-MAT, and give the matrix and then matrix name, and give number of times to be repeated row wise and column wise. Okay, so REP-MAT of A 2 times row wise and 3 times column wise will bring in this one like. So there are 6 columns. There are 2 by 2 matrix. So 3 times column wise is repeated and 2 times row wise is repeated. And character 1:127 will 127 will print all the characters of a keyboard. Yes. Now, so there are arithmetic operators like plus to add, minus to subtract, star to matrix multiply, power to matrix power, backslash or left matrix divide, slash or right matrix divide, dot star or array multiply, dot power array power, dot slash array right divide, dot backslash array left divide. Basic arithmetic operators are used in the matrix sense. Star between implies matrix multiply, so its operand must be of appropriate side. Slash is used to solve the equation. Backslash is used to solve the equation. A star x is going to be. Slash is used to solve the equation. X star A is going to be. Dot star array multiply is used to perform point-wise multiplication. For example, to evaluate squares of numbers. So I want to square the numbers, array of numbers -1 to with interval 0.1 to 1. Okay, then I can use y is equal to x dot star x. When I do that, I get the square of the numbers of each one of the elements. Okay, for example, you see observe 0.9, the second element, it has become 0.81. Okay, and now we can do a lot of manipulations with the arrays. We can work with arrays in MATLAB very easily. For example, let us see. Let me input a is equal to 1, 2, 3, semicolon 4, 5, 6, semicolon 7, 8, 9. If an error comes, it will throw it in red. I have not given the initial square bracket. So if I do that, it will come. I can pinpoint any element in the matrix 1/3. If I put A is 1/3, the third element in the first row will be displayed. And if I want, I can carve out a submatrix 1:2, comma 1:2. It will carve out the first top 2 by 2 matrix from the 3 by 3 matrix, that is 1, 2, 4, 5 will come. A transpose returns transpose of the matrix. A greater than 0 returns matrix of size A with all elements equal to 1 if all the elements are non-zero. So A 2 comma colon will print all the elements of second row. Similarly, A colon will print the entire matrix as a column. Normally, MATLAB assumes all the matrix as a column. Okay, and we can also do Boolean indexing. A greater than access of those elements where the Boolean expression is true. Some useful predefined matrices like zeros of ZEROs, zeros of 2 by 2 size will throw zero matrix. Once of 2 will throw 2 by 2 once one matrix. E by I of 2 will give identity matrix of size 2. Okay, and some useful predefined matrices design. Now I want to find the diagonal of A, okay, which is 159 should be the answer. I get that. Then I can also create a magic number of matrix of any size. For example, if I give 5, it will create a magic number of size 5 by 5 matrix. And now I can do some useful functions that operate. Let me call, I can, now the magic has been there in the workspace. The general name given to that is answer. I can allocate that to any, this one, arbitrary matrix. So I put P is equal to answers, then that is get transferred to this. And I can do triangular lower of P can be obtained by putting TRIL P, TRIU of P will give this one upper triangular matrix. I can flip from left to right of P can be done. Okay, the leftmost will become the rightmost, rightmost and become the leftmost. And also I can flip up down of P. Okay, so these are all the very interesting operations which can be done very easily in MATLAB. Now consider the matrix. I'll see we are going to do various matrix manipulations. For that purpose, we define a matrix A. Capital A is equal to 1, 2, 3 semicolon 4, 5, 6 semicolon 7, 15, 9. So I got the matrix. Now what I do is when I type there's a command called max of A. Okay, when I type that, I get the maximum. Row containing the maximum value is given. If I put max of max A, the maximum element contained in that row is identified. So I can also say find A equal to 6. It will tell the location of 6 in the matrix, counting column wise. So if you count column wise, the location of the element 6 is 8th element, so it is there. I can also identify j equal to find of a equal to 6. That is, I can find the indices of the element a is equal to 6. It is comes as 2 and 3. Then I can also I comma j find a equals max of a. When I give this, I have not given the so it gives the maximum element which is occurs in the third row, second column. All the built-in functions work on columns in MATLAB, like sum, mean, standard deviation, and all. You can also specify a dimension along which you intend to operate. So let us create a matrix of size x is equal to -10 to 10 at intervals of 1. When I say sum of x greater than 3, okay, it will return how many numbers are greater than 3. In this, from 4 onwards to up to 10 is greater than 3. There is around 7 numbers. We'll get the answer 7. How it does is when I say x greater than 3, it makes all the elements less than or equal to 3 to 0 and others are equal to 1. And when I say sum, it counts all the ones and then gives me the answer. Okay. Now, let us do some interesting manipulation of matrices. Okay. So I create, A is equal to, again, in MATLAB, there is a command called random. You can create that random number. Okay. And I want the location of the random number. Find max of A. When I find the max of A, it gives me one by one. So I also do the images C of. I put all these random numbers as a random color bar. It's generating. It will take some time. And then I can locate the maximum value. So color bar is located. I locate the maximum value by say I comma j is equal to find A equal to max of A, and then say hold on to hold it this one. So now I can use the handle to locate the that element with a marker. of size 30. Okay, in the figure. So at the location 27, 29, roughly around 27 and 29, you see a circle which indicates that location of the this one. You see this, so you see at 27 and this one you see a circle, so you are located. Okay, these things can be done with MATLAB. So command arguments are separated by a space. I can give a command directory star.m. Function arguments are enclosed within brackets with comma. Sign of x with x in the bracket, comma directory within quotes star.m will be the two commands which can be given in sequentially. Sign of x returns funny results. Many functions cannot be used as many functions can be used as commands. And other commands which we normally use is clear for clear variables in the workspace. CLC clear the command window. Variables are still in the workspace. Whose list the variables currently defined. CLF clears the figure window. Help displays the help. More toggle with a toggle switch on or off. More on or more off, useful when reading large files, L files. Type, for example, I want, again, if I give help, it will go like this. It will run, but I can also say that help with a pipe command more. Then it will, sorry. Okay. I put more on help, so it stops at that. Then again, to get the next page and all. The type lists the contents of the M file. Print the current here. So there are commands. I can use Control D to come out of a command. Control D. You can say quit. Okay. To quit the MATLAB. And we have statements. What does semicolon do? Control structures, if else and switch case, all those things. Okay. I can get the MATLAB again. Programming constructs statements. What does semicolon do? Control structures. Semicolons ends the statement. We have then else, switch case, otherwise. We have while, end, for end, break, continue, return. All these commands are there in the MATLAB. Now we can use a programming construct, a semicolon at the end of the statement suppresses output to the screen, and we have an example with the if statement. If yes, so we need we have to initialize the count count equal to 0. Okay. And if x will generate x is equal to -10 to 10, and then say if x greater than 0, okay, count equal to count plus 1 semicolon, else count equal to count plus 1, and when I give it this command and then say count. Now, since the first value of the count is -10, is less than 0, it will put count is it will go to the else condition, so it will print. So I put wrongly count is a count plus 1. It should be count is count plus 2. So I can re-enter the program. And then change this to 2. So now when I say x, it will be 2, count it will be x is there. When I say count, it should 2 should come. As it has taken 1 already is initialized because of the, so I put count is equal to 0. Then run the command again. Now we say count, it will come as 2. Okay. Similarly, we can we can use let as a switch. So next program is CLC clear all. Next is let is given the value x. Okay. Now I switch let. Okay, the case with the curly bracket, all you are displayed with comma, and I use a separate comma to actually there are 2 commands, display and then the case statement. Okay. Otherwise, it will say case will be display. I need to give the command by this one. I can also give like this. When I execute this, since x is let is x value, it should be a consonant. Consonant will be printed. Then for executing a for loop, I write the command for k is equal to 1 to 10, comma, next command is a of k is equal to k star of k semicolon, then end. For end is constructed within the this one is come. Now if you type a, all the squares of the first 10 numbers will be printed. Now I have to execute a while loop. For that, I put k is equal to 5 as my first loop, this one. Then while k greater than 0, okay, yeah, print yeah, within quotes, k is given a general format per percentage, and then new line command n, and then within the quotes, comma k is the number to be printed, then semicolon, comma to end that command, and then give the next command, k is equal to k minus 1, semicolon, and end. And this is a full construct of a while loop with k being initialized. Then it will do 5, 4, 3, 2, 1, and then stop. Okay. Yeah. So extensive range of graphics, plotting capabilities, graphic output can be saved in a range of formats. Use the command print -t driver. All graphic commands return a reference called a handle. Each graphical object can be customized using set and get and set. In graphics, GCF is a command gets handled to the current figure. CLF clears a current figure. Multiple plots are drawn using the subplot. If I put subplot 2 to 3 generates 2 rows and 2 column plots. Okay, subplot. Comma 2, comma 3. Generate. So it has generated the 2 by 2 is, and the third plot is generated. So there are 4 plots, and out of which I have selected 3. So the one, it is counted like this: 1, 2, and 3. Okay. Now I can use command CLF. So it will clear it. Clear the figure, current figure. I can also close that. Okay. I suppose I after drawing the plot, you can freeze the axis which with the command axis. For example, plot x comma y axis will freeze the axis. I say x is equal to -10 to 10. Y is equal to x dot star x. Now I say plot x comma y axis -5, comma -8. So it is frozen between -5 to 5 and 8 to 8. That plot alone is shown. Okay. Now we can use CLF to clear the screen and close it. You can hold on to display multiple graphs in the same axis. If y is a matrix, plot command produces a curve of each column. For example, we say y is equal to rand of 10, 4 semicolon then I plot y. I get that one. So I get process. Yeah, legend is produced with the command legend. Legend box can subsequently be moved to avoid clutter. I can say legend. So it is empty. So as I say plot y. So now I can plot x is equal to minus pi at the intervals of 0.1 to pi. Then y is equal to sine of x dot power 2. I get the handle plot of x comma y. Okay, I get the handle. I get the plot. Then get h. Get h gets the current list properties. List of properties are given here. Then I set get h. All the properties are come. In that I set the line width. Line width is there. Line width is set to set in the handle. Take the parameter line width. You have to type as it is. Okay, so it is line L capital W. This one. So you take that. Instead of 0.5, it is made to 3.5. So you will expect a thicker line. Let us see how it has come in this. You see there's a thicker line. You can also customize the plot using tools in the figure window. They are saved in separate figure files. Now, here x is an array of dimension 1 by 1. If you are tempted to use x power 2, that would be wrong because that would imply matrix square operation. Think of dots power 2 as element-wise operation or a point by point. Plot command can take additional optional arguments. Supported line types are dash single dash for solid line, column for dotted line, dash dot for dash dot line, dash dot for dash dash line. Okay, and for example, plot x comma y with a plus sign. Plot same plot with x comma y with the plus sign as the element display will display. If you see the plot now, it is on dotted lines. Okay, plus sign. Okay, now I can. The color of the line is specified by Y for yellow, M for magenta, C for cyan, R for red, G for green, B for blue, W for white, and K for block. Now, in the plot command, x comma y, apart from I specify the plus sign color as red. Okay, specify the color at red. X, Y, okay. And I do that, you can see that. So this one are red, your plus signs are red, the rest of things are in blue. Yeah. curve joining them is in blue. Okay. Scripts are bunch of commands stored in a file function as inputs, outputs, and body. Only the value returned from the functions are visible in the call scope. Functions are can be profiled. And given the starting value and the number of iterates, generates them using x plus 1 by x. So for that, I have a script iterates.m. So I can say x naught equal to 1. I initialize x naught to 1. Okay. Then xs is defined as a null vector. Okay. Then for I is equal to 1 to 10, comma, x is equal to 1 plus 1 by x naught. Semicolon. Then I concatenate to x of s. X of s is equal to x of s, comma, x. Okay. Then I put into, I reinitialize x naught, store the value of x in the x naught, and then go to the next group, this one. I do this, and if I say x, yes, I get the values of this one. The same thing in the, I go to my location C, users, there user. Then into the documents. I have the, I already, there's a MATLAB file, generate, which is already stored, the program. So function its is going to generate x naught n. All these things are there. Now I initialize, first x naught is made to 1. Okay. N to 10. Okay. Then I say generate. So I generate. So sorry, I should give the argument list with the generate. So I put generate x naught, comma, n. When you do that, it gives the same values of the this one its values printed as answer. Okay, so this is another way of storing the. This one is a very important skill you have to develop in the MATLAB programming. And once you have, we can have functions, odd x returns 1 if x is odd, otherwise 0 otherwise. Similarly, function y is equal to odd x. We already have x. X is equal to its. So x is equal to say minus 10 to 10. Okay. So I'll say odd of x. So all odd number. So OD. So I should have double value. So odd, you can always say double of x. It requires a so we can have commands. We can have odd function. Okay, let us see help. We are stuck, so we'll say odd to find out how to use command. Okay, so there's no need to remember. We can always yeah. Here there is a odd part of a Laurent polynomial returns odd part. So returns the odd part O of the Laurent polynomial, and the polynomial O is such that it is given this. So that is why we are not getting the output. And let us say odd P undefined P. So you have to define the as a polynomial, then it will come. Okay. Let's quickly move to the rest of the things because this is a declaration, and then we can also have a function odd x. Then y is equal to rem of 2 not equal to 0. We can give a condition, and then according to it selected, store the above lines in odd m, invoke odd phi, then it will get the value of odd. Okay. Functions cannot be defined at the command line in the interpreter. Stores the line of required function in the file, normally using the name of the function with extension .m. Invoke the function using the name without extension and supplying the arguments. Help reads the first set of contiguous command lines. Name of the file in which the function is defined is more important. Only the variables returned from the function that appear to the left of equal to the sign of the calling function. A function may contain other function definition. They are accessible only within that function. Let us example, calling a function from a script, x is equal to input x, and here, and if I see, so I have this function x squared, so I can have already imported the x squared. So I open that, okay, and close this. This is the function. Now what I do, I say x is equal to input within bracket input x equal to semicolon. So I input a value of 5. Then y is equal to, I call the function x squared square of x semicolon. Then display, I should get a value of 25. I am getting it. Okay. So that way we can input a function and then give the main program as a script. So this is the simple introduction to MATLAB. Thank you.